sick flow. You are now listening to Evil Dojo. Dark Mage in the house with the sick flow. You are now listening to Evil Dojo. Dark Mage in the house with the sick flow.
Should probably cut it at the first song. You don't want to make an intro too long, right? Welcome to another late night edition of Coding with Dark Mage, Evil Python. I cannot be held responsible for what you do with this code, however basic and noob it appears from my perspective. I can see the possibilities, what someone can do with this stuff. And it all begins with just some basics and understanding sockets, basic network protocols. I mean, fuck, entire internet's run off this shit, so it kind of pays to understand it from a certain core level, be able to interact with it, right? That's why we like Python, because we can do shit mad easy in it. And dude be like, what can you do with Python? And it's like, what can't you do with Python is really the question. And even recently, I believe they are doing something that might allow us to actually have like real threads. Now there's been like hackish workarounds to like get real threads in Python for a while now, but it's another topic. I'm not a genius or expert on that either. I've just kind of read some blog posts, but you know, I've been on and off with Python long enough to know how good it is. And I've helped enough people with Python to know that I like working with Python. So why not make life easier for ourselves and work in Python, right? That's what we started doing last time. Was we implemented a very basic wrapping protocol where we generate an AES key at random every time we run a program, and we wrap that AES key. Apologies if my back's fucked up. I'm gonna be doing some crazy stretches while I just kind of mind dump and do my thing. So part of the problem is I'm not just like great talking and coding, especially while like standing up. You know, adding like an extra like activity or thing that you have to apply effort into, or like another vector that you like apply energy into. It's like every additional thing kind of takes energy away from the other thing. It's almost like redirect power from shields to thrusters, you know? Anyway, last time we were generating an AS key at random and wrapping it in a public RSA encryption, right? And then we were transmitting that to another program that would receive it and then decrypt based off of the private key that is attached to it, right? And the whole idea is that if you throw away the private key immediately after decrypting the contents of the encryption, like the AES key, once it like basically has the AES key, it no longer needs a private key. So you can just throw that away. It's no longer in memory. So now you have two processes that have an AES key that's been generated at random that the human hasn't seen, right? That the human is not privy to. And we don't want the human to be privy to if at all possible, because the ultimate goal is to establish a secure communications channel between two bot entities so that they can talk to each other and, you know, anonymously or like without like their communications being spied on, right? That's one of the major goals here, because in the development of this botnet that I'm very interested in, this Redking Hivemind, one of the initial goals in establishing these communication channels is to be able to exchange information about where in the network the individual node sits. Class, I want you to open up your textbook. Make sure that you've got it. If you don't, it's not very expensive. It's on Amazon. Our textbook today is Black Mass, Volume 1 by VX Underground. It's a very good book. It took me a long time to really digest its contents. And even still, I like to go back to it and kind of get ideas, because personally, I'm not a Windows developer, not a Windows hacker. I don't really live in Windows space, and I'm not really that interested in learning it. So a lot of the material, I kind of have to like think about it from a different perspective, because it's very Windows centric. But for what I am able to digest and what I, you know, have like absorbed faster than others, especially the Redking stuff in Volume 1, which is the last chapter. Let's see. We got anyone in the chat? Okay, that's cool. Hey, Nylarine. Welcome back. So, I'm going to read a little bit of, I'm not going to read the whole thing, but I want to just like, it's, you know, it's almost 1 in the morning. It's hacker story time, right? You know, it's time for some digital Satanism. Redking is a project to create a decentralized, autonomous botnet that is capable of code evolution. Though I did not accomplish all of my goals in this write-up, I will continue to work on this project until it is useful. This project is written in Kotlin, and simulations are written in Java. First of all, why the fuck? I haven't touched Kotlin, right? Like, I've done Java, I've done a little bit of... I never got into Android dev. Like, I got paid $60,000 a year to do iOS dev at one point, even though, you know, I really haven't spent a whole lot of time on iOS, but I picked up enough of it to figure shit out. And I think if you were to give me money and ask me, which would you rather dev on, iOS or Android? I'd probably say iOS, honestly, because if Objective-C is still a choice in particular, I'm not sure I'm ready or interested in picking up Swift. Although it is interesting. The fact that C-Lang has kind of like taken over or gotten such like prolific, I know I'm going off in a lot of directions, so just bear with me. The fact that Apple has kind of like dominated the compiler space recently, it's really interesting. GCC and C-Lang are basically the two forces we got in this race. I don't even think ICC counts anymore. Like does Intel's compiler, like, does anyone actually use that shit? Someone comment if I doubt anyone knows, but I mean, just hit me up. Let me continue reading. So, well, the point being, like, I learned Java in like high school, right? Which was like 2004 was when I graduated. And I've come a long way since then. And I think there's a lot of more interesting tools, more modern tools. But I think a lot of people who operate in the deep hacker space don't pick up the new tools or really like spend time learning new languages. And I'm certainly guilty of this too. I've tried to find as many excuses as possible not to fuck with Go or Rust all that much. And anyway, paragraph 2. A peer-to-peer hive mind. Redking is an attempt to create a network that can operate without the need for any kind of command and control server or supernodes in a peer-to-peer network. Additionally, I describe a relatively simple trick to allow the network of machines to solve an arbitrary optimization problem provided by the bot master. In essence, the goal is to create a decentralized hive mind that is difficult to control or stop. So it took many readings and rereadings and sitting down and playing around with stuff on paper to really understand what was going on with this paper, what's going on with this code, where this whole idea is going. But like, first, everything's written in a way is so intriguing. It's like, damn, I gotta dig into this. And certain, it's first pass through, not everything was immediately clear, and certain things I kind of had to translate into my own way of understanding. Once I did that, I got very excited about what I understood. And I believe that's an important transformative level up skill that anyone could pick up when learning a new thing, is how to translate the thing into your own language. Because everyone's got a different language. You might all speak English, but the way that you think about something, the words, the sentences that you might form, all of this matters. And the way that you phrase something might be very clear to you, but to someone else, it might sound like gobbledygook. So it's important to try and find many different ways to look at something when you're trying to understand it. So with that said, let's dive into some code. So I'm moving things around and I've got stuff that works. I'm not going to be able to show something that works right out gate. Maybe I might be able to. Let's see what I can show out the gate. Okay. Okay, cool. So I've got a bot running, sitting on port 6666. And I'm going to load up another bot. At 666. Actually, no, I'm not going to load the bot down here. I'm going to open up another thing over here. Instead, we're going to do the bot.py on 6667. So as you can see, each bot has a randomly assigned virtual address. The virtual address is basically a randomly generated double number from 0 to 1. For a long time, I was very confused. Why is the virtual address this? And there's also a part in it that I'm still kind of working through. that talks about different ways that the virtual address space can be used. Now, that's something up for consideration, and I'm certain that people might have ideas like right out the gate. But the whole point is that in a large enough network with a large enough number of nodes, imagine each one of these nodes, like maybe say they've got tens of thousands of nodes. Each one of them has its own randomly generated, from 0.0 to 1.0. So, this creates a pretty wide space of numbers that you can select from, right? So if you got like 1,000 numbers selected out of this and they're just randomly whatever, and you start connecting them up, and each one of them's got a certain number of edges, and you have like maximum number of edges. The whole idea here is that what we're going to end up doing is nodes are going to start exchanging addresses. You're like, why? The way that they exchange addresses is going to be based off a certain algorithm. What they're going to be doing is basically checking their neighbors. Like, given a particular node and another node, node A asks node B for its neighbors. And their addresses. And then you take node B node B asks node A for its addresses. And together you do some square root averaging type shit. And depending on the result and a particular tolerance, you decide to do a swap. You also introduce a level of randomness so that it's not like always not swapping. So there is a little bit of a coin flip mechanism to introduce like additional variety to kind of help not keep the system like too stable. But what happens is that over a large enough number of iterations across the whole network, you start to propagate values in a way where the distance between nodes approaches a particular distribution, and that distribution is kind of like a really nice smooth curve. So I found this really interesting once I understood what was actually happening underneath the hood. It's like, why is the virtual address space this? What are we actually doing with it? And then it makes sense. So you can actually do simulations on this without introducing the networking component, but by introducing the networking component, you basically step yourself towards one level closer towards actually having something that can be run across multiple machines. So, like, at the end of the day, I should be able to run these on different machines. Like, theoretically, this could be machine A, this could be machine B. And from here, what I can do is now over here, you can see that we've received a message. Message was just hello. All I've really done is I sent the text hello into a netcat connection to my local host at port 6666, which is, of course, the port that we're running this on. The whole reason that I'm doing it this way is that there's got to be like a seed phase, right? Like at inception of the network, we have to distribute information. We have to get all of the nodes the AES key. Now, if every node comes prepackaged with the private key and the bot master has access to the public key, then we can generate a random AES key and distribute it to all of those nodes so that once the propagation is complete, all of the nodes have everything that they need to talk to each other without the RSA keys. Because the RSA keys is entirely for distribution of the key of the symmetric key. Because once you have everyone's got the symmetric key, they can all talk to each other without having to worry about like anybody snooping in on them. So long as the box that generates the initial key is secure, and we can find a way to keep the key as far out of memory as possible. We might have to come up with obfuscation techniques and additional layers in order to do that. Because we're going to have to load the key into memory every time that we do communication between nodes, right? It would be nice if, I mean, it might even come to it that we have to build some sort of layers of obfuscation, in between the actual loading of the key and like unloading it, so that the way that we store it in memory when we're actually not using it, for instance, and keeping the amount of time that we like are able to visibly see it as minimal as possible, so that anyone who's trying to pry in and dig out, unroot our fucking botnet has to work really fucking hard in order to do that. That would be a particular goal to aim for. So when I hit Control C, I've got a little thing in there that checks if because on disconnect it doesn't immediately recognize a disconnect, but if it appears that the client has sent an empty request like 3 times in a row, then the loop will just disconnect and start waiting again. And I think at max we can handle however many connections that we specify, because we're doing this using async IO. Let me take my jacket off. Okay. So we just initialized the key manually, right? I sent it a command and it recognized the command, and it called the functions that we wrote last time to generate the AES key at random, and then sign it using the public key that is attached to the program. Now, something else that we can do. Now here it messes up because I haven't properly implemented stuff. And it was around this point that I realized, oh, I should probably write this as like an actual class oriented, object oriented type setup in order to ease the development process. So let me kill and rerun that. Now, you just noticed something there. I actually got this bot to talk to this bot using a command that I sent from over here. Now, this is just the beginning of what we're going to scale up, right? The the first bot in the series is the one that generates the initial AES key. From there, it has to distribute the key to all of the other nodes in the network. There's certain problems in this whole process that have to be addressed as we get things working. Like, for instance, how do new nodes come online? What happens when a node wants to connect to a node that has no room? How are connections, distributed? How do we know what is or isn't in the network? So any particular node will only know certain things. And unless you happen to know the IP address of one node, then you don't have any. I mean, that seems kind of obvious to say, right? Um, However, one thing that the paper talks about is that the virtual address space sits on top of the real address space, and essentially all that really means is that it's just a variable that we can declare. It doesn't have to be more complicated than that, because at the end of the day, in order to do real communication, I mean, even just two nodes on a network, like a real network, like a computer to computer network, you have to use sockets. Now, what I want to do tonight is copy code over, listen to music, chat with people, talk about the idea that I'm working on here, and get a lot of what I have working here in an object-oriented form, so that as I start piecing the additional primitives forward, it's not a total pain in the fucking ass. I think that's a reasonable goal. What do y'all think? It's what, like 1:30ish? Why did I choose Python for this? You like the Pokemon thing? There's a GitHub. If you look up Pokemon Say, I'll type it in the chat. If you Google for Pokemon Say, the person's Possatti, Possatti. Why did I choose Python for this? I mean, I kind of explained this earlier. I don't know if you may not have been around. It's just, it makes things so damn easy. It was like, what can't Python do? And you could say proper type checking, and you're like, okay, well, you can write Python in a way where it's kind of safer, right? And you don't even have to use, like, what's that thing called? That, like, that that like additional syntax that I hate, where it's like type annotations. Yeah, I fucking hate type annotations. Um, like I never found them to actually be really helpful. Like every time I've sat down to try and use them, um, I found it easier to just like hand roll your own type checking. Like you can do that in Python. It's really not that hard. It's fucking great actually. You can just straight up do your own motherfucking type checking. Goddamn. Like people be tripping balls about type checking and shit. Holy fuck. Like dudes be like, oh my god, Python, I can't do that. Well, you could do this straight up like a equals 1. And then you could be like type a, right? Class int. And then you could be like my int type equals type of type of a. Yeah, we just do straight up like that. So now you'd be like my int type is class int. So now we can say b equals 1, right? Type of b, also class int. So what happens if we do my int type equals b, right? False. Wait, what? God damn it, Python. Are you fucking kidding me? Holy shit. Oh, no. Sorry. I am retarded. Backtrash that. Backtrash that. I am retarded. True. As expected. Okay. I'm not an idiot. I'm just a little bit jumpy. An idiot couldn't get this far. Let's just start there. But point being, you can do your own type checking. There's nothing stopping anybody from doing this. It's really not that bad. Okay. Let's get back to it. This is a lot of the working code that you just saw. It's a lot of async stuff. I'm feeling a little bit nervous about translating async stuff over into a object-oriented framework, but I don't actually see any real reason to feel averse to this. It's gonna be all right. So, what do we have so far? So I'm breaking up into 2 classes, right? And at the end, and ultimately, we're probably gonna end up having to move these into 2 separate files because ideally, when these things propagate, knock on wood, God loving that, we get this far. When these things propagate, we're not going to want to include the bot master in the setup, obviously, right? We're not going to want to distribute the private key, or rather, the public. Yeah. We're not going to want to distribute the. Well, wait, no, we got a flip flop. It's actually, I got it backwards. I do that sometimes. So the bot master is actually the one with the public key. Yes. Because it signs the AES key with its public key. The bot receives that, decrypts it with its private key. Now it has an AES key. Key in crypto. And yeah, the bot master. Well, yeah, because the bot master is being defined as a subclass of the bot class, because essentially they share a lot of the same functionality, but the Redking is going to have additional administrative capabilities so that if we ever need to like shove updates to running instances, for instance, one of the goals is to be able to distribute code updates and like introduce, like, let's say I want to add a function to, like, let's say I've got like 1,000 bot network and we've got one bot master chilling at the front of all that connected to like and here's the cool part. So the bot master would only have to tap one node in order for any sort of propagation process to occur. So I could be running with the bot master on my own shit, maybe, and then ping a known entry point into the network, and then everything just kind of goes from there. That's one of the goals. Let's see, where do we go from here? So I'm kind of copying over a lot of stuff from bot.py. So init AES key, we need to. So this is actually the thing that's gonna be generating its AES key, right? So if the bot master is the thing that actually distributes the key, it's going to be the thing that also initializes it. So let's start by copying this over. I'll get some good music on here in a minute, and also some snacks. So we're no longer doing that. Oops. If not is initialized, and it's not even that anymore. Not self that is initialized, and now we need to. Every time you have a new method in a Python class, you have to always remember to put self as the first parameter. Otherwise, it won't work. Self that is. Do I have to say super here actually? Because it's. I mean, I wouldn't think so. I mean, with proper inheritance, right? But you know, Python can be wonky sometimes. So actually, this would be self dots. These also have to be self. Okay. Oh wait, that's unit test. Okay, so let's start by creating bot master, right? On whatever port it is that I pass in on the command line. Okay, good. So init AES key we're going to want to probably call on a init, but to start with, before I make decisions like that, I like to break things up. When we do it manually, we'd be like, ESQ. Now if we go back and we run it, uh-oh, I didn't import something. Oh yeah, I need that. Might need RSA as well. P64 also. There we go. Okay. So far, so good. So once the let's clean this up a bit. Okay. So once the bot master generates the key, gotta get that key to some bots, right? So this is where the bot and the bot master start to share functionality. The bot and the bot master both need to act as effectively client servers that both have the ability to sit around and wait for requests as well as send out requests. And what we want to do is be able to do a direct communication with the bot master, who will then connect and deal with other bots. So effectively, we'll have like one bot master to begin with, and then two bots connected to it and each other in a triangle formation. And one of our goals, because all three of them would have their own virtual address, is to exchange that virtual address with each other every so often. Because remember, I was talking about the way that the addresses get swapped is based upon a function across the addresses of the neighbors of the node that you're considering swapping with and your own neighbors. So you take a look at your own neighbors' addresses, you add them up, or you multiply them all together, and then you like square root them. And then you do the same thing with the other set of nodes. And you also introduce like a coin flip mechanism into this. And depending on whichever result happens, you may or may not get a swap, but a swap would occur every so often. So in theory, you would see these addresses potentially swap, or these nodes swap addresses every so often. So we want the bot master to basically sit around and start listening for connections, right? Run server. This is where I'm a little bit iffy about exactly that this is going to work right. So I'm just going to piece little small bits of it together at a time. So both the bot master and the bots are going to have some async action. Man, we got some motherfucking ad bitches up in our shit. Goddamn. Shit's popping though. Hope everyone's having a great night. A lot of people up on YouTube, a lot of people on X. Only one person on Twitch. And the one person on Twitch is getting fucking nuked right now because we don't do advertisers. Especially ones that come up with shitty fucking Unicode Zalgo text trying to bypass filters and blockades and shit. I appreciate trying to hack my stream, but that ain't it, Chief. Back to it. Where are they going? So we've already initialized the AES key. Now server is going to be an await object. That calls a function. So this should be a object on self. So it'd have to be self. We also want to, keep track of that. Of course, this is, I am doing zero error checking at the moment. We're mostly just trying to get shit working. Once we have it working, we will go back and try to break the ever-loving fuck out of it and try to get it into a state where any sort of bad shit that I might throw at it, we properly handle in a way that doesn't totally like one of the goals that you should have when you're trying to deal with errors is exit gracefully, right? So we're certainly not going to be exiting gracefully if we try to fuck around right now, but we'll get there. So self.run server. And then async with self.server. And is Copilot smart enough to figure out this part? No, it's stupid. Holy shit. Is Copilot shitting a brick right now? What's going on? I'm actually surprised that Black didn't yell at me about the formatting there. Are we ready to test? No, we don't have handle client. Okay, handle client. Here we go. Self-reader writer. Do, 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 do. Let's see. Really, black is that some fucking Pep 8 shit? God damn it. I want my dual spaces. I want my dual new lines. God damn it. I'm gonna fucking turn over my fucking desk. Oh my god, I'm so mad right now. Okay, cool. Lines. Can I like specify lines to black? Someone help me out. Don't make me Google it. Googling it. Um um I guess black doesn't I guess it's like inside classes for Pep 8. Um it is fucking it's a strict Pep 8. God fucking damn it. I hate Pep 8 so goddamn much. You have no idea. What a fucking awful. I like black, but god damn it. Oh, this fucking okay. I just want dual lines in between my fucking class functions. God damn it. I don't want to have to do a whole lot of research just to do that right now. So we'll just keep pushing on. Greetings, viewers. Watch me fucking rage. Hope everyone's having a good night, though. Don't mind me getting mad at the computer. All right, so now we have to write self.handle request, right? Da, da, da. Okay. Let's get some fucking music on. God damn, I need some vibes. I need some fucking vibes. I need y'all to chat at me. I need y'all to tell me what your skill level is. I need you to tell me what you're currently learning. What's the most interesting thing that is on the horizon for the year in computings and programmings and hackings? Give give me your predictions. Just chat me up. Like, come on, like try it. I want y'all to actively try to distract me from getting stuff done, because the longer that it takes me to actually do this, the more content time that we actually get to fill. And not to mention, it's going to take me years to actually perfect what it is I'm trying to build here anyway. So this is a slow road. There's absolutely no rush. But I'm not going to take the time to research fucking code formatting right now. Jesus. I've been fucking around with some Suno tracks. Do you want to go heavy or do you want to go soft? We want to go fast. We want to go slow. Okay, this is pretty good. Let's see here. Handle request. Now it's not global key anymore. It's personal self request equals init. Actually, yes. No, we're not making anything, goddamn. Right, so now we want to do this. But it would be run server for the bot master. And actually, I think we have to restructure our entry point a little bit. There we go. Okay, so bot master spawns up and it's AES key, and then we run it. Let's test to see this much works. Uh-oh. I didn't import it. Run server, duh. Need to add cell or the bot master. Server. Oh, self.server, my bad. Yeah. There we go. Oh, yeah? What's good? I'm actually doing something VX related right now. So, I hope you have a copy of Black Mass on hand, because there's some material at the end that I find very interesting. Black Mass Volume 1, we've got this thing called the Redking Hivemind. And there's a lot of stuff on here, but and I've rambled on for over an hour about stuff, but it's a way of thinking about network architecture, and I want to apply it in order to have basically a little Python botnet, but one step at a time first. Before we can get there, we are reorganizing the code that we already have working into a bit more easy to work with, object-oriented style implementation. So this is actually a good checkpoint so far. Oh wait, no, we don't want that. No, we oh, we want restore. Okay, there we go. There we go. Let's see. What's next? Oh, we should actually test that the connection actually works. Okay, so it's chilling up here, right? Now down here, we're gonna do like, no, we're gonna netcat. Boom. Look at that. Very straightforward. Nothing magical happening yet. Everything takes time. So that works as expected. This is all good so far. Just remember, the bot master is just a bot, just like all the other bots, except it's going to have the ability to seed all of these other bots. So so this is the original code that we're working with, and we have not moved over a handle connect bot yet. So at the moment, this code over in the new code is unhandled. However, we'd be able to get this just dropped in pretty fast, and then we can actually run another bot and then do the connection test again. Because when we have bot master and then two other bots up, we're going to get the bot master first connected to the first bot. We're going to connect the bot master to the second bot, and we're going to find a way to force, either through direct implementation or something else, probably direct implementation just through like commands, to tell, through the bot master, tell one of the nodes or one of its neighbors to connect to another one of its neighbors. And that way we have that triangle formation. We may not finish everything tonight. We might save some of it for later, but we'll see what we do. A special Evil Dojo guest has awoken from her slumber. Who wants to say hi to my dog, Gracie? Oh. Hi. Whoa. Big yawn. She's a sleepy baby. Whenever she gets up, one of the first things that we do as we go make sure that she doesn't have to pee-pee right away. And she's actually so good that whenever I take her outside, the first thing that she does when I drop her on the ground is try to go pee-pee. So we've established this relationship over the years where, generally speaking, in the more recent years, it's been me, but someone would take her outside to do her business, because at a certain point she became incapable of doing so herself. But other than that, she's in pretty good health, and so she's hanging around with us. She's my baby now. So let's go do some business real quick. We'll tell the people we'll be right back. When you come back in, we'll do some Wawa and maybe get a little meat treat. That sound good? That way I can crank this music up for the people. All right, yeah, this is more my speed. So let's see. My girl's signaling that it's time for bed. We're gonna do a few more things here, and then we'll call it quits afterwards. But when we get to a particular checkpoint, like I demonstrated earlier, I was able to spin up 2 bots, and through Netcat, use 1 bot to connect to another bot. Because ultimately, we have to do that in order to distribute the key. So we want to be able to do that here. 2 separate programs. One spins up the bot master, another spins up the bot. We'll go through the same process. Previously, we were wrapping it all into 1 program, but we had no object orientation whatsoever. This makes growing the program a lot more difficult. This is why I spent so much time in the very beginning of like programming school, putting you through the paces of like properly implementing things from the ground up, really understanding all this stuff. In the very beginning, it seems so dumb and so retarded, and it seems like it's holding you back. But especially as you start to work with larger and larger code bases, and you begin to work on very specific pieces of a much bigger project, being able to break things down in this makes things a little bit easier. I wish I could type really well from this position. Let's try it. Let's see. Handle connect to bots. I'm gonna want like a nice print library too to like do good print stuff. Now bot main is gonna be basically the same thing. I need to move it slightly to the right. There we go. Okay. Where's everybody at? Okay. Yeah. Boom. So, for instance, we would do but no indication that it's running. We would like a little bit more info. wonder why fucking Copilot is shitting a brick right now. Node not found in path. What? Oh, I can't live with that. When did I fucking break my node? I would kind of like Copilot right now, damn it. What is it? Node.js? What is it? It's Node.js. Okay. Okay. I wonder if... Okay, yeah, we're back. We're back. Okay, we're good. We're good. There we go. Okay, so in theory, imagine we have another bot. So in actually, which one are we running over here? Okay, yeah, we're running bot master on the left. On the right, we're running bot main. Now we have two of them running, right? So let's talk to the first one. Okay, very straightforward. Let's talk to the one on the right. Very good. Now, let's init the first one. So it's got the key already initialized and it dumps it back out to us on the screen. Now let's get the bot master to do its first ping to the one on the right. Boom. See that? That corresponds to that. So we have established the first communication. This bot doesn't respond with anything yet, but I believe this is going to have to be kind of like a handshake protocol where when we tell it to connect, instead of connect, maybe instead we should call it like push key, right? Because ultimately, instead of sending ping, what we want to send is actually the key, right? Now, here's the catch to this whole setup. There's a race condition. And this is one of the things that has to be thought through during the course of my research is when we're thinking about the instantiation of the network and the growing of the network, there is a period between the node getting spun up and the node being seeded or configured with the correct values in order to establish communications on the network. And it would be nice to be able to create a sort of fail-safe situation where we can reject malicious nodes or somehow identify them if they happen to get onto the network and then eject them from it. Mm. Or rather, yeah, a virtual address like that. So here we do receive requests. We're going to handle request. If the request's not init, we do need to kind of do a little bit more command parsing here. If request, actually, this would just do connect and then do that, but then we send over the ping. Push key. Host port. Yeah, I'll do. Command parts equals request.split. Command equals command parts of 0. If cmd equals push key. Host and that, and then we can await that. So instead of handle connect to bot, we're gonna call this push key to bot. So connect to bot, and it's actually now going to be called push key to bots. Instead of writing ping, now let's just verify how bot initially worked. Because initting the AES key, what's the actual thing that we need to transmit? What? Right here. Jesus. The LSP's not working right. It'd be nice to be able to jump around Python definitions too, goddamn. It works pretty good for C, but need something else for Python. There's actually crypto. And then we have to encode it before we send it, right? So it's crypto. Okay, so with the same setup, we would be able to, instead of using the command connect, use push key, and instead of transmitting just a simple ping message, we would be sending a string that starts with the word key and then is followed by the contents of self crypto. But instead, maybe it is, oops. Instead, maybe we don't want the key like that. Because when we go to decode, it's like, for instance, when we actually init the AES key over here, it's already decoded from UTF-8. So when we encode it for transmission, we're going to have to decode it again. Actually, no. It's we do want key. So crypto is what gets transmitted, but then from this is how we actually load the key. So the so first we have to get the bot to receive the key before we can decrypt it. So let's get that far. Oops. Okay. All right, we've got our two bots running. Let's make sure that the bot master is initialized. Okay. Let's has to ping over to and actually we need to make sure that the bot is not able to initialize itself. Only the bot master should be able to do that. So we can say hi over there. Now it's time to do push key localhost 6667. Uh-oh. Notice something interesting here. Now we have an actually interesting problem that we have to deal with. The size of the buffer when it was reading in was not large enough to transmit the entire key. Now we actually have some real code that we have to fix. So let's take a look at where we're sending and where we're receiving. This is only reading 64 bytes at a time, which is not a lot. So default read size equals, and we're gonna double that. All right, so we're running the bot master again. We are running the bot main again. We're gonna check initialization status, and we are going to push key. All right, so what happens if we were to attach the word key to the front? If we have some sort of identifying marker, then the bot on the right would be able to listen in. All right. So we can actually have a little keyword at the front, um, indicating some sort of command to the bot. And then this can be a parameter. So this can be actually the start. So let's finish up here. So when we go down to receive request or handle request, right? Maybe yeah, we could start with just key. Man, typing like this is a little bit tricky. All right, so not if command equals ping, but if command equals key. Not request. Encoded, encrypted key. Okay, so then we base64 decode the encrypted key. And then we would decrypt it with this. And self.key would then equal decrypted key. I believe this is right. And so at this point, the bot would have the AES key having been unwrapped from the RSA. And unless we wanted to do, because no, actually, the whole point is that, like, may or may not want to throw away the private key. And actually, we might end up doing tests, A/B testing to see whether or not this will be a big deal or that we need the private key later on once we actually have secure comms established. Because then each node can just send encrypted blobs over. We don't have to worry about stuff. But if ever I wanted to sign commands so that we know that they came from a certain origin, like myself, then we wouldn't want to get rid of the private keys because they would be necessary for validation. Let's test this out. I didn't mean to exit all the way, damn it. Okay. All right, bot master's running. We're running a new instance bot main. We're going to go and init the bot master. And we are going to push key. We're going to send the command push key localhost 6667 to the bot master, which will then push the RSA encrypted AES key over to the bot. All right, so it received the request, but something didn't work right exactly, so we're gonna figure that out. Let's see. Okay, so command was not recognized correctly here. Received request. Self.handle request. Did this get called? Handle request. Oh, it only handles it if it's initted. Okay, so this is this is gonna block until we comment it out for the moment. I realize this code is not in the best order. I'm not gonna worry about fixing everything right away. But let's start up here. If not request. Request that. Now we can get rid of that and pull everything back a little bit. Command equals push key. We're not handling a ping at the moment. Okay. I don't like that. So after the init happens, we need to return. All right, here we go again. Oops. All right, that's initialized. Here we go. So it received, it printed, the same. Okay, so I mean, it recognized the key, but it didn't print anything else out like I was expecting. Handle request. We should print out what the command is at the time of receipt. Just for debugging purposes. Where's my hat? I need my black hat. Okay, there's our initialization. There's our push key. It received the key, it received the command. It prints out what the key is at the time of sending. But let me drop this window a little bit. Okay. Okay, it prints here. But then something shits a brick somewhere along the way here. So let's so we have to decode it from UTF-8 when we receive it, right? And this actually waits for a response from the bot, but we're not even sending that yet. You know what? Give me a second. I could use a little boost. A little boosty. A little boosty goosey. Here's a good one.
Allah says it is time to get stoned. Smoke up all the weed till you're in the fucking zone. Knick-knack, paddywhack, give a dog a bone. Hit in the bong from my motherfucking throne. Allah says it is time to get stoned. Smoke up all the weed till you're in the fucking zone. Knick-knack, paddywhack, give a dog a bone. Hit in the bong from my motherfucking throne.
Need a little bit of metal too. Okay, yeah. All right. No, but see, handle request. Okay, so it goes in and decodes it here, right? Remember that in initialization, this is like random bytes. This public key, it's loaded in from this plain text. And where the resulting encryption is just random bytes that we have to base 64 encode. So for instance, we could print when we decode from base 64. It's perhaps something is getting broken along the way. Especially if there are like any null bytes or whatever. Oh, that's a good step. Now, something borked. Perhaps we did not decrypt correctly. Pardon. I think I just realized. Because, yeah, the code for decrypting the key is incorrect. We never actually loaded the private key. Like, there was a similar loading step that we're supposed to do. Very similar to this. It's like the equivalent for the private key. Except instead of pub, it can be priv. And actually, we could try to print out some shit. We can get a little bit more info. There we go. That's what we fucking want. We managed to get the decryption key. So given this big long base 64, which is an RSA signed AES key, we have transmitted that from one bot to another by telling it to via an external command. So if you want to create like a completely self-contained network where all the nodes can do, it's like you'd be like pulling a ripcord. Effectively seeding these bots so that they can talk to each other and nobody else can, unless you have some sort of override. But effectively now, if we wanted to do like a little test, okay, so we still have to load the key, right? So self.key, right? Like this is now like that key here is the key that we transmit. Why are we loading Fernet? Oh, I guess, yeah, we're not actually I guess this is just the key storage. Okay. Jumped around. Fuck. There we go. Yeah, so we're going to create a new Fernet object. Message test message equals hello world. We encode the bytes. We encode those and we encrypt those bytes. I don't want to decrypt it. I just want to print the encrypted message out because we'd be able to send this encrypted message back over to the bot master. The bot master could receive it, decrypt it, and then that's proof of secure encrypted comms. We're almost there. And I think next time we will go through the process of doing the virtual address swapping using that mechanism. And that way we'll be able to like observe the whole process of them going through the back and forth of swapping, and we can actually start running some simulations at that point. That's going to be a lot of fun. So all right. So it received the bot received the key from the bot master. It decrypted the key, and then it used the key to encode the message hello world. Now we have to transmit this message back, right? Now we have to also decide on an appropriate length, like maximum length, because we have to consider that our messages are encrypted, so the message length is going to be significantly longer, you know, for the encryption, right? So let's get some stats on the length of messages, right? So instead of hello world, let's do something retarded like a times 32. And length. $140. Really? That's it? For 10 A's? I mean, this, you can see that's significant blow up, right? So, like, or sorry, that's for 32. Okay, so for 32 is 140. I would expect it to double if it were 64, right? So remember, 140 184. Okay, that's not too bad. So it, you know, like as we increase in length, it doesn't scale 1-to-1. It's not like, you know, it's not like it's going to double if the original input length doubles, which is kind of nice. So let's so there's like a base amount of encoding that occurs, and things get blocked together. But let's consider, and actually one thing we might consider too is also zipping our messages before we send them, and so that way we could actually have like significantly long messages. That way, that would be nice. So at any rate, what we want to be able to do is send the message back and have the bot master receive it. Don't start vaping. Bad idea. So we actually don't care about this right now, but now that we have this encrypted message, and it's just bytes too, handle request. We need to pass the writer. We need to pass the writer in the handle request. Okay, so the corresponding receiving end of this send is going to occur after init key. Or no, push key. We're going to need to read more than one tip. Very simple refactoring tip. Like let's undo that for a moment. So this is where it was at, right? We just created a new variable to replace the hard-coded 100 over here. And this way, you can modify this line a lot more easily than you can modify with the 100 inside the parentheses. Navigating to that point in the code takes longer than it does to navigating to this, because you have less things to iterate through. Not to mention, this also makes it so that you can start moving things so that your variables are all together and that you have just chunks of code that do one thing. You'll get mixed opinions on where you should declare variables. I often start off defining things in the middle of the code and then later on pull things, especially things that are like, if I can, I want them old style, which is to say all the variables declared at the top of your function. Kind of how, like, you know, proper OO is done. You have all your privates in one area, and you know, all your publics. Of course, we don't have public and private in Python. You just have to fucking know somehow. We are coding off the rails, and my music has stopped because Suno doesn't know how to change pages. Here we go. Yeah. We want this to be way more than 100. We want this to be like 1024. So we do we need, okay, so we encode it here, then we get our bytes, then we write the bytes. But yeah, it is base 64 encoded. So let's see what we receive, what we have to kind of unwrap, because we're steps away from just, you know, being able to do this. Uh-oh. Error decrypting key. Was it not? Let's see. When I handle requests, okay. So when we handle client, oh, ooh, wait. Okay, no, that's okay. So it's passing the reader and writer in from its own stuff. Um, hmm. Let's make sure that we're not passing none to handle client. No, I mean I'm certain that it's not none at this point. But for some reason I feel like it's not getting passed in properly here for some reason. Hmm. Handle request. If wait. Okay. It worked that time. I don't know what the fuck happened then. But so we should be able to something goes wrong here. Oh wait, no. Error decrypting key. But it actually sent. So maybe I did something right, but something's also incorrect. But it received it receives this, right? Here we go. Yes. Look at that. Welcome to Evil Dojo, everybody. We have established secure communications between two bots. The bot master is a special bot. And the whole reason that we have it set up like this is that we use the bot master to initialize or seed this bot with its randomly generated AES key. In this way, I, as the bot operator, never actually see what that key is. And maybe for one reason or another, I might keep a copy or store it somewhere. But otherwise, keep it away from my eyes and other people's eyes so that nobody else can start to decrypt what it is that the bots might be talking about. What are they talking about? Who knows? That's for us to decide. In this case, we said, welcome to Evil Dojo. But in other cases, we might be instructing things back and forth with each other, right? So, one thing that would be useful as it can, as we establish connections, as we do this initial information exchange, because we're gonna have to handle a lot of different commands. One command that we're gonna need to handle is the advertising of a particular node's virtual address. So one of the issues I can see, since each connection has its own thread, we're gonna have to find a way to associate each effective thread managing a connection with the virtual address associated by the node that it's connected to. And the reason that we have to do that is that whenever we hit a node, not only are we going to want that node's particular virtual address, but we're also going to have to be able to do a computation on all of its neighbors. And part of the first step in making that happen is being able to do this initial exchange where Botmaster says, hey, here's what my address is, right? Because we can see this right here. We're printing it out over here too. So this is 0.09, this is 0.88. So now that they both have an AES key, we have to be like, here's my virtual address. And it has to go, here's my virtual address. And it has to know that it's talking to, in particular, localhost 6666. And that this is talking to 6667, right? So we don't want these connections to last forever, but we do want like a clean exchange to occur. So in getting a better protocol kind of rolling, one of the things that I want to do is be able to say, hey, expect us to send this key, and then it say, okay, awaiting key, and then we actually send the key at that point, and then it goes, okay, we've received the key, we've verified that we can decrypt it, we're all good, and then send a message back saying the operation was successful, and then clean sign off. A lot of that takes time, and it would be very hasty to rush out there and just start throwing a lot more together than this. Although, just thinking forward, because, as I've mentioned before, we're going to establish this triangle connection where the bot master and two bots can all talk to each other. And in doing so, be able to get information about the virtual address of itself as well as neighbors. So actually, take a look at I have code that works that does some of this already, but getting into the operations of the sandberg swap, right? Here's what we do. So you have nodes A and B, and you get the neighbors of A and you get the neighbors of B. And you have two B values, D1 and D2, and they both start at 1, or 1.0. And for every one of A's neighbors, you multiply D1 by D1 and the absolute value of the distance between the location of A and each neighbor of A. And then you do the same thing for B's neighbors. But you also do this product onto D1. And then for every one of A's neighbors, you if the neighbor's not B, you multiply into D2. D2 times equals the distance between B's address and the neighbor's address. And you do a similar thing for B's neighbors. For every one of B's neighbors, if the neighbor's not A, you take the product and multiply into D2 the distance between A's location and the neighbor's location. And then once you've done this, so you've already run 4 loops at this point. Once you've done all that, if D2 is less than or equal to D1, then you perform a swap. Otherwise, you determine a swap probability by taking D1 divided by D2. Then you just roll a random number, and if the random number at this point is greater, or rather less than the probability, then you do a swap. Otherwise, there is no swap. And so over time, the idea is that, at a large enough network, certain items settle in such a way as that they don't really change all that much, so that you can have some sort of guaranteed fastest path between 2 points. You get login communication. I found this really fascinating. It's just a really interesting data structure to explore. So thinking forward, right? Thinking about how this exchange is supposed to work on a functional client server level here. So one question I would have, and I don't have the answer to it right away, with the async IO framework, like, is there a way that we can print out like the number of current connections? Because if there's a way for us to kind of like so okay, I got it. The only thing that we have to store is the virtual address for the neighbors. So let's think about it, right? So long as we keep that list updated properly, so whenever the swaps occur, right? Like whenever a node changes its own virtual address with another node, we have to update the list. So whenever a node changes its own address, we would have to update all of the other nodes so that they have update lists, because the only other way we would be able to do it is by polling all of the connected nodes. And actually we might actually have to keep track of the addresses and ports as well. So we would have to advertise what port we're listening on, because every especially if we're testing all from localhost, we basically have to inform every bot. Like, so we're gonna have to keep track of the host, the port, and that other thing I said. What was that other thing I said? God, I gotta pee. Think. The virtual address of the neighbors. The host, the port, and the virtual address. Alright, I'll be right back. All right. I think for the rest of the stream, I don't know how much longer I'm going to leave it on, but makes me feel a little bit motivated to get some of the better, like, basic feedback, like the REPL kind of going for some of this initial exchange, because one of the things that should happen if we fail to decrypt here is that we should reject the client, like part of a test that what if we have a malicious actor trying to invade the network and they try to feed us this bogus fucking encrypted message? I might actually go to bed, but it is a final thought. Just the next steps for really cleaning this up and making this like really, more tight. It's gonna be about handling all of the different bugs and problems that can occur when all the variables don't line up. But so far this works. This was my goal setting out, and we achieved it. So, hell yeah. And I hope everybody can see where we're going with this. The idea is it's not mine, but it's kind of a clever, interesting one that I've wanted to explore for a long time. So, YOLO. I hope everyone had fun tonight. And hope they learned something new. If you like all of this shit, if you actually hung around for this long, holy shit. Mad thank you. Please continue to watch, like, subscribe, and support all my shit. Because we are in this shit for the long haul, baby. We got people on X, Twitch, and YouTube. So, thank you again for hanging out this long. It's a long stream tonight, but it's a chill one. Until next time. Yeah, I got stuff I gotta do. Hopefully in the near future we're gonna be coming at you from a new location. I don't know how much longer it's gonna be until then, but we are on the quest. So, everybody, take it easy. And until next time, always be coding.